Welcome to the Algebra 1 3.5 journal, Graphing Linear Equations in Slope-Intercept Form. This starts on page 81 of your journal. Don't forget to use the pause button when I ask questions. Try to answer them yourself. Always test yourself. Always try to make yourself better. Vocab, let's start here. Rate of change. That is another term for slope. That's a popular term now for slope. So you may hear rate of change in other questions. They're just asking you to find the slope. Find the rate of change, find the slope. M, that's a non-vertical line going through points x1, y1, and x2, y2. Vertical line has undefined slope, we say. Over here, we got some equations for slope and formulas. Slope equals m. M is our symbol for slope. Rise over run, that's a ratio. Change in y over change in x. So rise is the change in y. Run is the change in x. y2 minus y1, that's a change in y. x2 minus x1 gives you your change in x. So again, if you can get it from the equations over here, rise over run, the change in y, that's the change in y values. So the run is the change in x values. Again, you can see that down there too. Slope-intercept form. I should mention, we use these often in counting out the slope on a graph. So whether we're graphing the line or finding the slope of the line. Slope-intercept form, this is a key concept throughout a lot of stuff in here. A linear equation written in the form y equals mx plus b, so that's our slope-intercept form right there. This isn't in the books, but xy is a point on the equations, or a point on the line. So that can be, a lot of times, it's just the x and y there. Sometimes we're plugging in a point to see if it works. But the points that make that equation true make the line. M, as we mentioned before, stands for our slope. B stands for our y-intercept. Those are things you may or may not have known before. Some of you knew them. Got to know them now. They come up a lot. You'll be using those for the rest of your high school math career. Constant function. Constant function, what that means is constant value of y. Okay, this is another form of a linear equation. This is the long form of it, though we don't usually see that written because 0 times x always comes out to 0. And so usually we'll have to do this. So remember, when you see this, it's, your slope is equal to 0. That looks like junk. M is equal to 0. Also remember, this is a horizontal line. When you see that, if you see x equals, that's a vertical line. Now, I should have mentioned this earlier before. All this is on page 136 in your book, or 138, or you can see below. They have a lot of this below. The book has a lot more examples and prettier color pictures. Here's that equation I gave you before up there. You can see I'm counting it over here. Your run x2 minus x1, your rise y2 minus y1 on there. This would be a positive slope. We'll talk about that a little bit later that they're showing you. Finding the slope over here. I recommend labeling your points. Come over here. Label them. x2, whoops. I like to do x1, y1, x2, y2. Doesn't matter which one you call x1, y1, x2, y2. But remember, it's got to be the x and the y together. It's not x1, x2. It's an x and a y together because that's what a point is when we graph it. Then just plug them in over here. y2, that's 3 minus 1, which is y1. x2 is negative 4 minus 1. 3 minus 1, that's 2 over negative 5. That would be my slope. Oh, how'd we get to that page so quick? I used the pause button. I always forget my microphone. I think I'm talking into the computer, but the microphone's not on the computer for this. Okay, slope here. This is a key visual concept. Okay, so this is something you got to look at. Positive slope. Okay, as you go left to right, it goes up. This would be a bigger positive slope, like 2, 3, 4, 5. A smaller one's going to be a little flatter. And then 1, slope of 1, it goes up just as fast as it does. That's about a slope of 1. Negative slope. As you go left to right, it goes down. Again, this would be like a -4, -5 slope right there. This would be like -1/3, -1/5. We'll work on that below. We've talked about this slope of 0. This is our equation x, not x equals, y equals 3 or something like that. Undefined slope, that is the equation x equals 3 or something like that here. Undefined slope, just so you know, if you use that y2 minus y1 over x2 minus x1 and you get -4 over 0, that's what we call undefined. We have that 0 in the denominator. So that will give you the undefined slope. Estimating by drawing. So this little note here, just about what do these slopes look like? Just remember, 1, for every 1 it goes forward, it goes up 1. A slope of 4 is going to be a really steep positive slope. Both of these are positive slopes, just like this graph right there. 1/3, that's going to be that flatter positive slope. Okay? And again, pause this. Try to get these before you draw them. Don't just copy it. Try to anticipate it, check and correct. Slope of -1, that's going to be going down. Again, this is down 1, forward 1. It's -1 over 1. It goes down just as fast as it goes forward. -1/2, well, that's closer to 0. That's that smaller absolute value. That's going to be a flatter slope. -3, but it's still negative. It's still negative like we have up here. -3, that's going to be a steeper negative slope. It's still negative. As I go left to right, it's going down. Okay, let's get rid of that. Here's some more on your slope-intercept form right here. These are key concepts. Again, remember, M is your slope, B is your y-intercept. So B, it can be written as 0, B, because remember, that's how we find it. If you think back to the last section, to find the y-intercept, x equals 0. That's what that coordinate looks like right there, 0 with the y-intercept. Key concepts to remember, you should be able to identify these on in an equation or on a graph. So again, try to get these, pause it before you see my answers. What's the slope? What's the y-intercept? Well, our slope here is -6, which you might think of as -6 over, not negative, over 1. That's the rise over run form. Our y-intercept is 1. Sorry if I answered that slope before you could pause it. So again, pause it before you try to answer these. This is a special case of a line if you look at the equation. Then get the slope and the intercept. Okay, hope you paused it. This is the special case of a horizontal line. That y equals is a horizontal line. That goes back to our, I went by it here, our constant function. Right there, the y equals b, we got a slope of 0. Oops, too far. So that's a horizontal line. Our slope is 0. Our y-intercept is 8. Again, because remember, y equals mx plus b. That'd be y equals 0x plus 8. That's why there's no x there. It's times 0. This one I got started for you. You've got to solve it for y. So use algebra to rewrite it. Minus x minus x. I put the x first because that's closer to the y equals mx plus b format. Now I got negative x over 4 minus 10 over 4. Don't forget there's a 1 in front of that. So that's like negative 1/4 x. 10 over 4 reduces to 5 over 2. That's going to give us a slope of negative 1/4 and negative 5 over 2. That's a more challenging one. If you got that one, good on you. Okay, let's do number 2 here. Describe the slope of the line. I look at this. This is a positive slope. That's my description. Positive, negative, horizontal, vertical. Those are your descriptions. Then find the slope. I'm going to use my m equals y2 minus y1 over x2 minus x1. Now this positive is a good thinking thing here. x2, y2, x1, y1. That gives me 4 minus a negative 4 over 3 minus a negative 1. Notice the minus from the equation and the minus from the points both need to go in there. That goes to plus a positive. That's going to give me 8 over 4, which reduces to 2 over 1, or just 2. So my slope is equal to 2. I should also note I do have some scrambled answers on this page. Oops, there's my positive answer. There's my 2, so I can check those. Now 4 and 5, this is using slope as, remember, delta x over delta y. Remember that means change in x. So if I look here, my change in x is 1. I got this backwards. This should be change in y over change in x. My change in y's are 0. This equals 0 over 1. That's a slope of 0. That's going to be a horizontal line. Y equals negative 2, I bet. And that's all you're doing to find the slope with those. For 6 and 8, you want to use y equals mx plus b form. Now there's some tricks I'll talk about with this form as in standard equation. We learned another way to graph that. And I got some other tricks I'll talk about in class with that. But we can solve this minus 6x minus 6x. That leaves 4y equals negative 6x plus 24. So we're solving this to y to get it in our slope-intercept form. Divide by 4. Remember, this means negative 6x over 4 plus 24 over 4. I got to divide both parts. This can reduce. Negative 3/2 x. 24 over 4, that's 6. So I got a slope of negative 3 over 2. And I have a y-intercept of 6. Again, if you need some extra space on these, use extra space. And then you can check that over here. There's my slope. There's my y-intercept. Okay, last one. We only got a few seconds left in this video. A linear, this is going to use the change in y over change in x concept, the rate of change idea here. Models a relationship. The dependent variable is always the y. Decreases 6 units. For every 3 units, the independent variable, that's always x, increases. So my change in y, 6 unit decrease, that's going to be negative 6. 3 unit decrease, that's negative 3. So that's going to come out to 2. That's kind of weird. That gives me 2, or 2 over 1 if I need it. The value of the function at 0. Well, the function at 0, that would be the coordinates. When your function is 0, that makes it the y-intercept. so my y-intercept is 4. Now